love saying that. Hola! Hey! As what can I say but hello out there. And alien guy, you came back right on. Yeah, I heard you went on this really long, like 365 light year trip or something, so he's back. Yes. Let's go ahead and get started with our video. What happened to my slideshow here? It looks so weird like. There we go. Ooh, I pushed the right button for a change. Mr. Wara, there's hope for you. Yes, one day you too will figure out how to use this stuff here. You're my practice group. Here we go. Topic C, making like units numerically. We're coming to the close because we're looking here at lesson 13. There's only 16, 4 more to go. So let's go ahead and get started and take a look at our objective, that wonderful purpose that we have that directs us every time we do math. And there it is right there, objective. It says the students will be able to use fraction benchmark numbers, and we'll talk a little bit more about what those are, to assess the reasonableness, what's reasonable, okay, of addition and subtraction equation. What's really interesting on this particular lesson, we're really going to be looking at mental math. But of course, we're going to go ahead and start off with the application problem, and this is really, I think, just more of a review. Ooh, we have some more Christmassy looking like paper here, huh? A little theme paper. Santa, remember? He got zapped with like this green snowball. It was really cool. Anyway, I don't know if you were there, but yeah, it was pretty cool. Anyway, let's get started here. It says Nathan. Nathan, our friend, he jogged 3 5/7 kilometers. Okay. His sister jogged 3 4/5 kilometers. Wow. And 3/4, that's almost the same. You know what? Let's change that up. That's too much the same. I need to do this because obviously she's a little bit younger, so it would be like a little bit less. Let's take 1 off, huh? It's not like I just change that like that. I do it. Yes. Smart lets me do it. It says, how much farther did Nathan jog than his sister? So let's go ahead and take a look at that. We'll go ahead and set up our wonderful tape diagram. These things are getting to be a little bit easier the more that we do them. Isn't that all about math? Just practice, practice, my friends. Makes perfect. That's what I learned when I was growing up. Okay, this is Nathan here. And then, of course, then we need to make one more of these here. And so you can see. And we'll put sister. Okay, now we're going to go ahead and put in his amount, which was, scratch that, 3 5/7. Okay, and she was a little bit less, so that's 2 4/5 kilometers, because that's basically the unknown here. When we look at that 4-step problem solving, we've done this before, where we read to understand the problem really well. Then we start coming up with our plan, how we're going to solve it. And then, of course, we look and we do our solve. So we actually solve for the problem. And then finally, we check back and we check our work. Okay, we also talked about how we can do the read, draw, and write. So we're looking at here to finding the difference here, which is subtraction. So we're trying to find that out. So 3 5/7, subtracting 2 4/5. And of course we can break this one apart. We've done this before. Method 1. And that way we could go ahead and take the 4/5 away from that 3 wholes right here. Okay, that's going to leave us with just 1/5. Because there's 5/5 in 1 whole. And then we're going to go ahead and add on the 5/7. Okay, now the 3, this is something else. I should actually think of it this way, not just the 1 whole, but we're also subtracting the 2 from the 3. So 2 4/5, 1 more fifth gives us 3. Therefore, we only have 1/5 left. Okay? So now we're just adding. We're getting our common denominator, which many of you may see is 35. Multiplying those. And then we're going to go ahead and get 7 up here. And then here we're going to have 25. Now we see we have 32 over 35. And not quite 1 whole, almost. So in this case, we're going to go ahead and put the Nathan jogged, that's my reasoning, jogged 32 over 35 kilometer, okay, more than his sister. Okay, and I just see that kind of running out of room there. Okay, let's go ahead and go to the next slide. Let's get focused on our concept development. Okay, now we have this big problem right here in the middle. Ooh, and stockings in the background, very cool. Nice theme there, Mr. Wara. Okay, what we're going to be doing on this particular one here is we're going to be really looking at trying to solve problems without doing any really solving on paper. Our goal here is going to be, during the last couple of weeks, what we've basically been learning is strategies how to add and subtract unlike fractions. And what we're really going to focus on today here is to focus on mental math. And this is important when we look at numbers, that we practice mental math. We're going to be using the reasoning, okay, without actually solving this on paper and pencil. So the first thing is I want you just to look at this expression and kind of think to yourself, if we didn't use paper and pencil, about what this quantity is, and it's just looking at the fractions. So I'm going to go ahead and kind of share some of my perceptions or understandings of these fractions. First, I can say that I know that like 1/2, okay, 1/2 is 50%. Okay, I happen to know that. It's also like 50 cents. If we're talking about money, 1/2 is 50 cents of a dollar. I know 2 halves will make 1 whole. I also know that a half is, we're written is actually 5/10. I know that there's many equivalent fractions that we could actually write. 3 over 6. Okay, you get the idea. 20, right, over 40. So this is basically trying to get an understanding. The biggest thing is that it is actually 1/2, a half of 1 whole. Now, even though you see me doing all this writing down, and we're trying to do this mental math, what I'm doing is I'm sharing what I'm thinking, and I'm just jotting this down so that you can see it. But I'm not doing any solving. I'm just trying to understand. Now, when I look at the 3/4, one thing I know that is that with 3/4 is that 3/4 is more than 1/2. That is more than 1/2. And also that it's less than 1 whole, and it's 75% since I was using that. It can also be written as 0.75 in a decimal. Okay, and it would be considered like 3/4, like of a dollar. If you think of a dollar, it's 3/4. So what I'm doing here is I'm kind of creating a picture of these fractions so that I can better understand if I were to evaluate them being added with each other. So one thing I can state then, having done all this work here, is that 3/4 is more than 1/2. We stated that. And we would just need a half more to get our answer greater than 1. So if we have 1/2 here, and 1/2 we know we would have equal 1. So since I have 3/4, 3/4 is larger than that 1/2. Therefore, that would be greater than 1 whole. I'm going to just go ahead and slide some of this stuff down here. Give myself a little bit of room. I like how the lines come on over. There you go. So I'm just going to go ahead and open this up. So that's one thing we can say about the problem without having to do any solving. Okay, that 1/2 plus 3/4 is greater than 1. Okay, and you saw how I kind of was thinking that through. Okay, we'll go on to the next problem here. Now we have another expression to take a look at. Again, we don't want to calculate. We're just kind of trying to understand the value of this expression. Okay, definitely I can see this time we have subtraction. as indicated right here. Now, what do I know? Some things I do know is that in this case, I can see that, 2/5 is less than 1/2. Okay, that much I do know. 2/5 is less than 1/2. I know that because half of 5 is 2.5. That's just a little bit smaller than 1/2. I know that 2/3, on the other hand, 2/3 is larger than 1/2. I can see that here because when I think of that model and I break up into thirds, the 2/3 is going to go over the halfway mark. Also, you may recall that by looking at a decimal, the 2/3 is the 0.66, so it's above 0.50. So knowing that already, I know I actually can't take 2/3 away from 2/5, as 2/3 is actually larger than 1/2. So when I subtract, I actually can't take that away from 2/5 because of that. So I would actually need to take it away from the 1/2. You can see that. Okay, so then the question becomes, is this value, the value of this expression, is 2/3, when we subtract 2/3 from 1 and 2/5, is this going to be greater than 1 or less than 1? Well, by looking at that, knowing that 2/3 is larger than 2/5 means that I'm actually going to have to take from the 1/2. And that lets us know that our answer must be less than 1. So that expression is actually going to be less than 1. Okay. Mega less than 1. Okay. So you can see that by the fact that this was larger than the 2/5, it means we're going to still have to take from that and makes that number smaller. All mental math that we're looking at right now. Now we have 4/10 plus 1/3. And again, we're just evaluating this expression, looking at it. What can we understand that will make it so that we can figure some general understanding of the value without actually having to solve. This is really important. This is what we mean by benchmark numbers. One benchmark number is the half, comparing a lot of these to 1/2. We're assessing the reasonableness of the answer without actually always coming up with the answer. Well, 4/10 we definitely know, right, is less than 1/2. Because 5/10 would be 1/2. So we know this is less than 1/2. We know that 4/10 is going to be closer to 0, right? Rather than like 1/2, as it's less than 1/2. And also looking at this 1/3, is it closer to 0 or to 1/2? That looks like it's going to be closer to 0 as well. And we do know 1/3 is less than 1/2, because when half's being broken up into 2 equal pieces, where thirds, you can see those pieces are going to be smaller. So 1/3 is going to be less than half. This is going to be less than half. Then the question becomes, well, is this answer going to be more than 1? No, not going to be more than 1, right? Because both of these are less than 1/2. So it can't be more than 1. Will it be more? Will it be less than 1/2? Well, looking at this, 4/10, you can see just 1/10 is going to make it exactly half. So 1/3 is definitely going to make this greater than, 1/2. Okay, so this expression will be greater. However, this expression will be less than 1. Okay, 1 will be greater than that. Okay? Seem pretty simple? That's all we're doing right now. All mental math, my friends. Mental math. This will be our last problem, so let's go ahead and take a look at this one. Well, I haven't given you anything, have I? Let's see. What do we want to do this time? Is it trying to do that to me again? Okay. Let's just do it slower. Now, keep in mind, there's just one of those. So, that first one was kind of and then we'll do this. Okay. And then we'll go ahead and continue on with our work. Let's see. Different color. How about red? Yes, red. So we have here 2 1/3 plus 3 1/5. Ooh. And then we're determining is what, by evaluating this expression, is that going to be, I guess, less than, greater than, equal to 6 plus 4/10. So let's just go ahead and kind of evaluate this one. The first thing we're definitely going to need to do is to estimate the total for both equations to determine, right? Then you can actually compare them. I'm going to first add up, I think, the whole numbers on the left-hand side, and then I'll go ahead and compare them, because they're larger place values. And when I look at the 2 and the 3, of course, I see 5. And over here, I see 6. Pretty close in value there. Now, if the whole numbers are equal, then I'd estimate the fractions too and compare them. Sure, we have another whole here, but we don't have that. We have these unit fractions of 1/5 and 1/3. And because these fractions can't possibly add up to actually get to 6, it's going to be less than 6, you can see that immediately I can say that this expression is less than that one. Now we did that without doing any solving. This is the key of this particular process, and that is a letter, by the way, okay? And we did it without getting a common denominator. That's the key thing. Now, I'm going to give you the rest of the code word. There it is. You're like waiting for it, like, come on, Mr. Wara. You know what? And that concludes this video, my friends. It's time to say adios. Hasta la vista.